The digital timer on the control panel ticks down to 0. The alarm sounds, the mixing cycle stops, and for most, the job feels complete. But the process hasn't actually ended. The physical ration still has to navigate its way out of the heavy machinery, pass through the discharge doors, and transfer smoothly into the downstream delivery system. The physical behavior of the material, how it surges, thins, or clumps, provides a direct look at ingredients interacting with internal surfaces. The timer at hidden narrow is actually the start of a phase where the physical performance of the ration finally becomes visible to the operator. Understanding this phase requires watching the continuous behavior of the entire batch as it empties. Inspecting a single isolated handful of feed isn't enough to verify if a ration is actually uniform. This movement breaks down into 3 phases. First, the early phase captures the initial fraction dropping through the outlet. Next, the middle phase flows at a steady rate. Finally, the late phase reveals the remnants clearing on the sheen. In a functioning system, the physical appearance remains consistent and moves at a predictable speed. When an operator knows what this normal flow looks and sounds like, they establish a baseline signature. This makes it possible to recognize a developing abnormality long before the feed reaches the cattle. Imagine a run where everything seems normal until the late discharge, when a sudden, heavy surge of long roughage pours out of the chute. It's natural to look at that symptom and immediately conclude the mixer is broken, or that the ingredients weren't loaded in the right order. However, cattle rations are naturally heterogeneous. They are made of diverse particles with different weights and textures, meaning that 2 individual handfuls will rarely look identical, even in a well-mixed batch. A visible anomaly during discharge doesn't automatically prove a mixing error. Instead, it functions as an early warning that something in the physical environment has changed. Troubleshooting requires following a specific sequence. Observe the symptom, take structured samples across the entire discharge, and verify the facts before changing the equipment settings. The investigation often leads to the physical interaction between the specific properties of the feed and the mechanical geometry of the mixer itself. Factors like moisture, particle length, and stickiness dictate how a material behaves as it moves toward the exit. Inside the machine, ingredients interact with the auger flighting and the discharge door. These components aggressively separate particles based on physical traits. Friction and surface tension cause smaller, wetter particles to cling to surfaces, while larger, drier materials flow past unhindered. This mechanical drag forces certain ingredients to lag behind. This means a perfectly mixed batch can actually become unmixed purely because of how it is forced to leave the machine. If a batch that normally empties quickly suddenly takes much longer, it signals that the relationship between the feed and the hardware has shifted. An anomaly at the discharge door suggests the physical environment of the machine has altered the ration, which usually requires mechanical maintenance rather than just more mixing time. Once the discharge is over and the door seals, the focus shifts to what remains inside the supposedly empty machine. Closer inspection reveals residual material clinging to sticky surfaces and packed tightly into the corners and welds of the steel vat. This creates the risk of carryover, the process where leftover material from the current batch unintentionally enters the next one. This residual material directly impacts the formulation of the next batch. These leftovers introduce unintended ingredients into the cycle, creating a risk that spans the entire production schedule. Managing these risks requires looking at the entire facility as an interconnected chain, rather than a series of isolated machines. We track the ration from the mixer, through discharge, across transfer conveyors, and into delivery trucks. These downstream points apply new physical stress. Vibration and agitation during transfer provide constant opportunities for feed separation before reaching its destination. The cattle ultimately experience the combined result of the entire system. Their nutrition depends on how the ration survived every stage of the journey. Monitoring the final discharge is how an operator manages the complete system, as the state of the final material often reveals where the upstream manufacturing process is starting to fail.